Okay, guys. So after that first week, we're ready to pick up steam a little bit, and we're going to be moving on to the next section in the chapter, finally, which is 9.3, and it is the area formula, but not just the typical for a triangle. We're still dealing with triangles. We're still doing trigonometry, but it's the area formula for a triangle that goes a little bit beyond just base times height. It's looking at how you can calculate some of those sides if you don't know the height, for example. And it's not that bad at all, so it's pretty easy. So I just want to take you through the idea of this area formula today and then show you two quick examples. And then I'm going to ask you to look at a problem to try it tonight with that, okay? So let's take a look at some notes that I have here. And if you look at this note sheet, which I'll share with you also the PDF here. So I have an arbitrary triangle ABC that you can see here. Now, it just so happens that if we're trying to find the area, right, you could rotate. I have B as the base just right now, you can see there. But you could rotate the triangle any way that you want to, and A could be the base or C could be the base, because all you want to know is the area. And the size of the triangle doesn't change if you rotate it, right? So I just made side B the base here for now, just because that makes sense. Base times height. We're used to the area of a triangle as 1/2 base times height. That's because base times height is the area of a quadrilateral, and a triangle, if you cut a quadrilateral, if you slice a quadrilateral in half, you end up with a triangle. So it's half of a quadrilateral, essentially. But beyond base times height, what I want to do is just take a look at how you can, if you know the measure of the base here, for example, but you don't know the measure of the height, depending upon if you're given angles and sides of a triangle, height is not an angle or a side of a triangle, it's inside of a triangle. So that's the part that you probably wouldn't know. I want you to take a look at how you can easily find that height, though. So we're assuming we're given some information here about the side lengths or the angles, but not the height. Well, for starters here, right? Let's say that we're looking at this blue right triangle that I have here. The height is, it makes two right triangles, blue and red, because the height is an altitude, right, which drops at 90 degrees. So the sine of angle A here is opposite over hypotenuse. And if you look at this angle, the opposite side is the height. That's why we're looking at sine, because it gives us the opposite. And the hypotenuse is C. So I have written here sine of A equals H over C, opposite over hypotenuse. The opposite side is H to A. The opposite side to A is H, and the hypotenuse is C. If you multiply C on both sides of this equation to cancel it out here, you're left with a formula for the height that I'm circling right now, which is C times the sine of A is the height. So jump up here to this area formula. Area is 1/2 of the base times the height, which we just found is C sine A. So this is a way of finding the area of a triangle if you know side length B, side length C, and angle measure A. I could do the same thing with the red triangle over here, and I could say that the sine of angle C is height opposite over hypotenuse A, right? If you're looking at angle C, the opposite side is H and the hypotenuse is A. So the sine of C is H over A, which means that A times C is that height. And that's what I have right here. That's another way of finding the area of the same triangle, 1/2 base times height, where the base is still this side length B. But now I'm just substituting instead of H, height equals A sine C. And that's what I've got in here, okay? Or I could rotate the triangle and get AC sine B. Bottom line is, look at how these formulas are made up. It's two side lengths and the angle that includes them. So BC, angle A is made up of side B and side C of the triangle. In this formula, angle C is made up of side B and side A. And in this formula down here in black, angle B is made up of side A and side C. So any of these formulas will give you the same area for the triangle, okay? And then I just have two quick examples here. So if we're given this information, which when you draw it, you're given side angle side when you draw that out. substitute it right into the formula. 1/2 of the two sides, the product of the two sides that make up the angle times the sine of the included angle. And if you put that into your calculator, you get 91.19 square inches. So it's just the product of the two sides that make up an angle times the sine of the angle gives you the area. That's what the formula says here. All right. The only way this can get difficult at all, and it's not even that difficult, is if you're not given side, angle, side. But what if you're given, as my second example shows here, side, side, side? So you don't have, we don't know, like if you want to use this 5 and this 7, we have to figure out what angle H is. If you want to use this 7 and this 11, we have to figure out the measure of angle J. If you want to use this 11 and this 5, you have to figure out the measure of angle D in order to get the area of this triangle. Well, we just did in the last section of the chapter that whenever you're given side, 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 you can find the area, or I'm sorry, the size of any angle by using the law of cosines, which is what I did here. So I just decided to find J, which means that I wrote, so I decided to use 7 and 11 and find angle J. That means I have to start and end my law of cosines with little j and big J to be able to go through and solve just like a problem from last chapter or last section of the chapter where I find the angle J. So look, if you look down here, this is just me finding the measure of angle J to be 19.68 degrees by finding the inverse cosine of 145 over 154. This is like a problem from section 9.2, okay? I stored it in my calculator. I hit STO alpha J, and then I just, that way I could just don't have to worry about rounding it. And I did 1/2 the two sides that make it up. So 1/2 times 7 and 11. 7 up here and 11 are the two sides that make angle J. So 1/2 7 times 7 times 11 times the sine of J, or just type in 19.68 and you will get that area, 19.96, right? I'm going to give you 1 or 2 of these just to practice that we'll go over tomorrow. And then I think Wednesday will be a good day to do a catch up. If you have, we'll do a Google Meet, I think, on Wednesday. Just if you have any questions that come up through stuff that we've been doing, it's a good time to get some one-on-one time as well. So I'll send out an invitation to that. It's optional. You don't have to come unless you have any questions. But please try the 2 problems that I'm going to type up into the Google Classroom post for today. Okay? Thanks so much.